Our teaching assistant for the day is once again Ash. I know he's a bit hard to see because he is all black, but he is super adorable and still available for adoption. Thank you for your participation, Ash. All right, today we're going to cover our first type of inferential statistics test known as chi-square. So this is what we use when we have a categorical independent variable and a categorical dependent variable. The first thing we do is we actually plot our two variables in a cross-tabulation table. And this is just a table that displays the frequency of the categories of one nominal or ordinal level variable with the frequency of the other. And then what we do is we use the chi-square test of independence or chi-square test of statistical significance to tell us if the relationship we're seeing in the cross-tabulation table is statistically significant or just due to chance. And the way that we do this is we compare the expected frequency of each of the variables within the other, if there was no relationship, to the actual observed frequency to check if they are statistically different. And we represent this test with the Greek letter chi and then add the top 2 to represent that squared. So let me show you what this looks like in SPSS. Using our monitoring the future data, I just ran a quick 2x2 cross-tabulation table on the gender variable and our age variable. So you can see here the columns are sex. We've got our male students and our female students, and our age variable less than 18 with 18 and over. Now what the table shows us is that under 18, we've got 265 male students and 389 female students. We would expect to see, if there was no relationship between gender and sex, 295 male students and 359 female students. You don't need to worry about how these expected frequencies are calculated. I know the textbook covers this, but since SPSS does it all for you, you can just forget about those calculations. They're not necessary. And then we also get the percentages as well to help us. So we can see here that about 50% of the female sample is less than 18, and about 50% is 18 and older. Oh, Ash came back. I guess he's the only one who actually finds statistics fascinating, apart from me. All right. And then for males, we've got about 41.6% who are less than 18 and 58.4% who are 18 and older. So it sort of looks like there's a relationship, right? Female students are more evenly distributed between the two age categories than male students. But is this actually a real relationship or not? Is it statistically significant? That's what the next table tells us. And the one that we want to read is this one here, the Pearson chi-square. This is going to tell us that this is our chi-square value, 10.381. Stop walking on the keyboard, Ash. This is the degrees of freedom we would report with it, and this is our significance value right here. So this is our p-value. Our p-value is less than 0.05. So that means that, yes, there is a statistically significant relationship between one's gender and one's age within our sample of students. Now, we also have a bunch of other information presented in this table. Most of it is not important. The only one part that is important is our assumption check. So the chi-square test of independence has basically one major assumption, and that is that every single cell in the 2x2 table is going to have an expected count of at least 5 people in it. And this note here at the bottom of our table, note A, tells us whether we've met this assumption or not. So it's telling us 0 cells have expected count less than 5. So it's telling us, great job, you met your assumption. You can report the chi-square value. If, for whatever reason, we did not meet our assumption, this note here would warn us. In that case, we have to use what's known as a non-parametric test. Non-parametric tests do not have any assumptions to them. That's what the non-parametric means. There's no parameters that have to be met for the test to be accurate. The non-parametric test for chi-square is, oh my goodness, I know you want cuddles, but I'm trying to record a lecture, is the Fisher's exact test. So if we violate this assumption, we just click a little tick box, and we also get this result as well. And it's telling us the same thing, that yes, there is a significant difference between gender based on a student's age. All right. We can't forget what we learned last week, and that is that just because something is statistically significant doesn't mean it's meaningful. So we need to look at the effect size. The effect sizes for chi-square are phi and Kramer's V. These are the two most frequently used ones. Phi is only valid in a 2x2 table like the one that I just showed you. Kramer's V can be used for any type of contingency table. So we can see that the value here is 0.086 or negative 0.086. The minus sign doesn't matter. It's just the value itself that is important. And when we look at this giant effect sizes slide, when we look at the Kramer's V or phi interpretation, we can see that we are between a weak and a moderate effect size. So we can word it like this. So research question, is there an association between student sex and their age? A chi-square analysis was used to test this relationship, and there was a significant difference in the age distribution of males and females. Males were more likely to be 18 years or older compared to females, and this is a weak effect. Kramer's V, I reported here. So this is the exact structure of how you will write up your own results for the SPSS weekly assignments as well as the final assignment. The way we write statistical findings is very prescriptive, so it all looks very similar because technically there's only a couple right ways to word everything and still have it correct. So you say whether or not there was a statistically significant difference. You say where that difference was, but only if it was statistically significant. If there's no difference, don't include this statement and imply that there is some kind of difference, and then comment on the size of the effect. One thing to note is that the APA manual has specific rules for how to report significance values. So if your p-value is between 0.01 and 0.049, we're going to report it as p is less than 0.05. If it's between 0.001 and 0.009, we're going to report it as p is less than 0.01. And if it's showing up as 0.000, we're going to report it as less than 0.001. If it's higher than 0.05, so if it's not statistically significant, we're either going to write NS for not significant, or we're going to write the exact p-value, all right? And as a reminder, the p-value is the probability that what we're seeing is due to chance. So with a p-value of 0.15, we're saying that there's a 15% chance that what we're seeing is just completely random differences and not actually due to some kind of real effect. All right, let's look at a more complicated chi-square example. So here I looked at the level of happiness and the race of close friends. So you can see that it's a much bigger table now, more complicated, a lot more information. Before you try to figure out what any of this means, start by looking at the chi-square table. Is this actually statistically significant and something that you need to interpret, or can you just skip on to the effect size? So when we look at our chi-square results, we can see, first of all, that yes, we have met our assumption of a minimum expected count of 5 for all of our cells, and we can also see here our Pearson chi-square value. So it's 18.244 with 10 degrees of freedom and a significance value of 0.051. So what this is telling us is that it's actually not statistically significant because our cutoff is 0.05, and this is higher than that. We can say it's approaching significance, but it's not actually statistically significant. And when we look at the effect size, we see, and again, we can only report Kramer's V because phi is not accurate when looking at tables that are more complicated than a 2x2 table, that it's less than 0.01, so that's a very weak effect size. And this is what it looks like written up. So the association between a student's level of happiness and the race of their close friends was assessed with a chi-square analysis. The results indicate that there is no significant relationship between one's happiness and the race of one's friends. This is confirmed by the very weak effect size. So there's all the information provided. All right, that's it for chi-squares. The next video will show you how to actually run this in SPSS.